question 5.2, they tell us that sine of 27 degrees equals p, and without the use of a calculator we need to get the following things in terms of p, or the following trig ratios in terms of p. So if you see this, sine of an angle equals a letter, you grab that thing and you start off like this. We firstly change this p to p over 1, like so. And then we're going to use the classic SOHCAHTOA. Okay, so in this particular case we've got sine. Sine is opposite over hypotenuse. That's what SOH is a shortcut of remembering. So the entity on top here will be the opposite side of the triangle, and the entity at the bottom here will be the hypotenuse of the triangle. And now we're going to set up a sketch that reflects that. And 27 degrees falls in the first quadrant of the Cartesian plane, so our sketch is going to be in the first quadrant. So let's get a Cartesian plane going and set up our sketch. And now we're going to draw the triangle in the first quadrant. You know, I always used to get confused, do I draw the triangle like this, or do I draw the triangle like this? And the bow tie helps you remember how to draw it. So this little shape here is called the bow tie because it resembles the shape of a bow tie. And we can see if we're in this quadrant, we draw the triangle like that. So over here, I'm going to draw the triangle like that. And when I draw the triangle, the 90 degrees snit sits snug over there. And then this 27 degrees is always the one closest to the origin over here. So I'm going to label this 27 degrees. Okay, now before we start labeling the sides, it's always worth our time to get this angle over here using interior angles of a triangle. This plus this angle will give me 180 degrees. So if I just say 180 minus 27 minus 90, it will tell me the size of this angle here. So let's go ahead and do that on our calculator. So we just pop that in, press equals, and we get 63 degrees. And then I like to put that in the corner here. And check at this, the next question, there's a 63 degrees, so you're more than likely going to be tested on it in most instances. Okay, now we're going to start to fill in the sides of the triangle. So this P is opposite. Now you may be wondering, opposite to what? It's opposite to this angle over here. It's all relative to this angle. So P is opposite the 27 degrees. Opposite the 27 degrees will be this side over here, so that's P over there. And the hypotenuse, this 90 degree angle always points to the hypotenuse, so this length of the hypotenuse will just be 1. And then to get the missing side in the triangle, we just do Pythag. So the Pythagoras theorem states my hypotenuse squared, so 1 squared, is equal to this side squared plus this side squared. So it's going to be p squared plus, and I'm going to call this x squared for now. So now the mission is to get x on its own, so we know what this side is. So 1 squared is just 1. I'm going to move this p squared over to that side of the equation, and it becomes minus p squared. And then I need to get rid of the square on x, so I square root both sides like so. So square root the side and you just get x. If you square root the side, the square root just stays over this binomial. So now I've got to replace that x with this big square root. And now I'm finally ready to answer the question. So cos of 27. Cos is equal to the adjacent over the hypotenuse. Adjacent just means next to. So adjacent to the 27 or next to the 27 is the 1 minus p squared under the root. So we put that on top. And at the bottom will go the hypotenuse. The hypotenuse is 1, so we just put 1 at the bottom. And anything divided by 1 just kind of stays the same. Like 7 divided by 1 is just 7. So we can simplify this to just the root. And now we've successfully answered the question. Cos of 27 degrees is equal to the square root of 1 minus p squared. You can also do this with the use of identities, but I find the sketch is a bit better. So let's see where our 2 marks come from. First mark comes from the correct diagram, and the second mark comes from the final answer. Alright, now 5.2.2, we need to get sine squared of 63. The square is a bit off-putting, so how you deal with it is like this. You just move it to the outside. These are essentially the same thing. They mean the same thing. If the square is there or on the outside, it's the exact same thing. Now that I've got sine of 63 inside the bracket, I'm going to use my sketch to change sine of 63 to the actual ratio. So let's grab Sokotoya and make that happen. Okay, so we're working with sine, so we're going to be using SO. Sine is opposite over hypotenuse, and it's opposite to this angle. So now we're using 63 as the reference angle. Opposite 63 is this thing over here, so I'll put that on top. And what goes at the bottom is the hypotenuse. The hypotenuse won't change no matter which angle you're looking at, so the hypotenuse is still 1. And remember, like the last question, 7 over 1 is just 7, so this over 1 just kind of disappears. And after we've simplified that, this square cancels out with this big root, and we just left with what's underneath the root, the 1 minus p squared, as our final answer. And last but not least, your 2 marks come from the answer only in this question. Okay, welcome to your challenge round. Your challenge round is 13.5. We need to get cos of 13.5. But I don't see an angle of 13.5 anyway, so this is a bit weird. What I do notice is 13.5 or 13.5 is half of 27. Or you can see it as 27 is double the size of 13.5. Double angles. We've got to use a double angle identity to get this thing. So let's have a look at our double angles. So we've got 4 possible double angle formulas that we can utilize, but it's very specific as to which one we need to choose. I don't want one with sine in it, because I won't be able to get like sine of 13.5, and I need cos of 13.5. So I'm going to choose this double angle over here. And I'm going to show you how we utilize this double angle to get this. Okay, so cos of 2 theta, I'm going to model this to be 27. Because then this theta will be half the size of 27, which is 13.5. And then I'm going to use the sketch to change this cos of 27. Or in fact, I think we actually got it earlier. Yeah, here it is. Cos of 27 is this thing over here. So let's change cos of 27 to the square root of 1 minus p squared. And after we make that change, the mission is to get this cos of 13.5 on its own. So how we start doing that is we move the negative 1 over and it becomes plus 1. After I move that over, I want to get rid of this 2 by dividing both sides by 2. These 2's will cancel, and then I'm just left with this big mess. I cannot simplify that at all. And then there is one last thing left to do. I need to get rid of the square, so I square root both sides. And what that entails is if I square root this side, the square disappears. And if I square root this side, I just put a massive square root over this thing, because I can't simplify it. So there lies our final answer. Yes, this question was a bit of a parked on prawn, bro. Okay, let's have a look where our 3 marks are coming from. The first mark comes from using this double angle identity. The second mark comes from the substitution of cos of 27 into the double angle identity. And the last mark comes from your final answer.